we wanted to see the most prominent topic mentioned in those documents, we will do topic modeling. Topic modeling is simple. Singular value decomposition is topic modeling. There are other algorithms also. I am covering only singular value decomposition based algorithm. The topic modeling and recommender systems are themselves a separate topic. Okay. So this I have taken 3 simple documents and did count vectorizer. I have got a rectangular matrix. Generally, eigenvalues, eigenvectors matrices will extract the essence of the matrix. If it is a covariance matrix, covariance will be extracted. If it is word-to-word relationship matrix, it will extract word-to-word relationship. If it is document-to-document relationship, it will extract document relationship. Right. So we want to understand word-to-word relationship because in a topic modeling, how frequently the words are occurring together and how frequently the words are happening overall. Right. So how many times a word occurred and how many times it occurred with other document. So to understand, we need to take a word-to-word relationship matrix. Right? This is the word-to-word relationship matrix. You can apply eigenvalue decomposition on this matrix, or you take this matrix and apply SVD. Right? After applying SVD, you take V matrix. U sigma V transpose. Right? When you apply singular value decomposition on a rectangular matrix, the matrix gets decomposed into U sigma V transpose. So in that V matrix you have to take. Okay, V matrix we have to take because it's a column to C transpose C matrices or X transpose X matrices. Eigenvalue decomposition is V, and XX transposes eigenvalue decomposition is U. Right? XX transpose is what? This is XX transpose. Right? Document to document relation. This is word to word relation. So when you apply eigenvalue decomposition on this, you will get the extract. Right? That extract is what will have the importance of words. So here word to word and overall word to word total documents relationship. So here these rows are also belonging to words and columns are also belonging to words. Okay. So if you look at this, I have taken enumerate of this matrix, VH matrix, right? The first row, right? Topic 1, and then I am actually zipping the feature names with the scores because each of this each of this score belongs to the words. Okay, deep has got this much score in the topic 1. Enjoy has got this much score, like that it is. Okay, so in real time you will not have only 6 words or 7 words like this. You will have millions of words, right? Maybe thousands of words, and you will take only top 10 or 20. So here I have taken only top 3 scores. I sorted the data in I think this sort is not right. I think when we looked into the give me 1 second. Yeah, this is right. This is a zip, right? So terms and components, right? And then we are sorting the data on components. Okay. If we print the scores also, where is score? Score. Give me 1 second. Sorted terms. Okay, that's okay. This is correct one. Okay, this is correct one. You verify it. Maybe there is. I got suspicion because when I was explaining dictionaries, right? We found some problem with the code I wrote, right? You remember? I don't know. 3-4 months back. Right? So am I using that here? No. Definitely no, because this is a zip statement. This is not dictionary, so it is not. So I have taken, and I know the key I changed in the sorted method. The key I changed to value. The key is the name and value in the zip, right? The terms are the key and the components are these scores are the values. So on these scores we're actually sorting. So we are taking the top scored words when we do this decomposition. So if we understand SVD, right, the topic modeling LSA algorithm is understood. That's it. Okay. Any questions here? Okay. So LSA algorithm, right? I have taken a bigger data set here. Here to understand, I have taken a simple data set, right? 3 documents. But here I have taken bigger data set. We have started building one healthcare product and we had to halt it. While doing that product, right, we scraped data from different healthcare company websites, and we had around 8,577 documents, right? These are all healthcare, web data, right? I think I kept this data set in the data folder. Let me check. But you can do lots of NLP tasks on it. That's the healthcare news data. No. Let me look at it. Let me look for that file. Hmm. Give me 1 second. No. Okay, I'll actually search for it. Maybe in the email I'll have it. And I'll download this and give it to you. Okay, this data has got lots of documents, and there is a lot of scope that we can do. Okay, so in terms of named entity recognition or that whatever experimentation, and this is like real time data. The 8,577 documents means it's almost like real time data. It is actually real time data. We scraped data from websites and we kept into CSV file. Okay, so I've taken the data. Even if I have to execute it, I need to have that, right? So research work, no. E-learning, no. Yeah, this is I found a web application here. Give me 1 second. Give me 1 second. I'll show you a web application for stock market prediction. Right? HPC data somewhere we should have. Healthcare product H. See this. Give me 1 second, okay? I'll have it here. Oh, okay, I'll find it. I'll find it. Maybe it is in the email, right? I'll find it and give you, right? So we have taken this data, but we were unable to, handle all these documents at once because it's a huge data, and memory was not sufficient. So we have taken only 100 documents here, right? And then looked into first 5 documents and did some cleanup, data cleanup. Okay, here we removed all the, new line characters, kind of characters, and then we kind of, took out, in the end of the document, right? There was some contact and the phone numbers kind of stuff. We removed that, and removed text in square brackets, removed words containing numbers, right? This is a mistake actually. Removing words containing numbers is a mistake because in healthcare domain there will be some codes which are related to drugs and devices. So our main goal here in this particular project is to identify named entities. What are named entities? Person names, company names, drug names, device names, right? And locations, right? Where all the, locations. And then at one point in time we have to understand the relation, right? So if we are talking about a person and Hyderabad, what exactly the person and Hyderabad is related to the drug, right? Using AI we should be finding it, right? It's not a simple thing. It's a bit difficult, tough thing to find out. So that was the main goal of this project. Okay, so maybe by end of the course, right, you will get a little bit of idea on how to do it. If you can experiment with this data, right, you will get a good hold on NLP. This is another project you should definitely do. First one, the anomaly detection. Second one, the IMDb dataset. The third one, this healthcare dataset. Okay, so if you can work on these 3 datasets, right, in industry, any problem you can work on, related to data science and NLP, right? And we have that computer vision project, right? This speed detection. If you can understand that whole, project concept and do some help there, you will be able to do any project on computer vision also. Okay, so we have everything, but the time is the thing you need to spend or I need to spend. Okay, so we wrote a method to clean up the data first, right? We applied, right, that cleaning thing. So on the data frame we called apply method, and then lambda x means every row will go here and come back and sit in this data frame. So the cleaned data is this one. Now I have taken Spassey's small model. Okay, I'll explain Spassey in a separate class altogether, but there will be language models, right? I need to explain language model also. What is language model is, initially when I spoke about corpuses, right, I said that human beings will take the data, take this kind of big documents, and then manually flag it, right? This is a verb, this is noun, this is something, this is something, like that they'll flag it, right? Using that flagged data, when you pass a new record, you can actually predict a word is a noun or a verb, because in 4 times this word occurred in a document. Out of that, 3 times it is noun. In a new document also, you can predict it as a noun. It may not be correct. Context sensitive POS tagging is there. Individual word, unigram, POS tagging is there. I spoke about unigram POS tagging. Okay, in a given document, in a given corpus, there is a word which occurred 4 times, and 3 times it was a noun. A new document is passed now, and you are going to predict that as a noun because 3 times out of 4 times, 3 times it was noun. So that will be done by this language model. Right? In this language model, there will be code that actually uses the corpus and tries to make prediction. Okay. In simple words, I explained. Did you understand what is this language model? Did you get it? Any questions? SPACY is another module like NLTK. Okay, NLTK is not used in production. Okay, SPACY is used. SPACY, Flare, and Stanza are the modules we use in production. So you need to definitely practice these three. Right, at one point in time you'll definitely get it. Right. So this is SPACY thing. I am loading a model here. This is a small model. There are small model, medium model, and big model. And the big model is about 48 MB, I think, size. It will have the corpuses and the code written to make predictions on the data. So I have taken this SPACY model and then tokenizing the data. What is tokenization? Splitting data into individual words, right? And then removed stop words and joined them again. So this data is the stop words removed data. Okay, now I am doing a TF-IDF vectorizer, and I can do right here in this topic modeling concept. What I did here, I did a count vectorizer model, count vectorizer representation of numbers. I can do TF-IDF also, right? TF-IDF will actually give scores to words which are more important, higher scores to words which are more important or moderately occurring, words. And then you do the truncated SVD, you get least important topics are not going to be highlighted. Got it? In this bag of words approach, most frequent words will get highlighted as best topics. Okay. In the TF-IDF vectorized data, if you apply truncated SVD, why truncated SVD? It will do, step by step. It will take, batches of data and try to do the singular value decomposition, right? So if you take a TF-IDF factorizer, it will give importance to moderately occurring words only. That way, you will get, the combination of moderately occurring words topics as the best topics. Got it? The way you represent the data, you get the output. The SVM, right, the SVD, singular value decomposition, is a technique. That's it. Whatever kind of data you pass, that kind of output you get. If you don't understand SVD, right, you don't know how to use it or why the model is not working. You may actually take a bag of words and pass it and it may not work. It may not be capturing the best topics out of it. Maybe there are too many unnecessary words which are repeating many times, and it is actually capturing those unnecessary words only. Spam words are getting as topics in the ultimate thing, right? If you use TF-IDF, right, if that is the case, if client compliance, right, you come down to TF-IDF factorization and then apply, topic modeling. Got it? Got it? Any questions? Right, in truncated SVD, we have got components underscore. Right, it will actually give you. I have taken 20 components only, right? 20 n components, 20 I have taken, right? And then you can actually take out of those 20 components. I have taken, the words, right? These are all the words, and there will be scores assigned to them. 4 to 5, 9 words, distinct words it found, and there will be scores assigned for each topic, right? We are going to take 10 most frequent topics. Take features for topics, right? So there are 0 to 19 topics, right? Components are the topics, and in each topic, what is the highly spoken about, the words, right? It is actually a data, it's actually a healthcare domain based data, and there were many documents which are related to Pfizer, because from Pfizer website we downloaded those documents. Okay, so it will not exactly bring out 100% whatever, but it will work at least 80 to 90% time. The thing it will actually bring out best topics. So the problem with AI is that only, right? The client's expectation is that it will work 100%, but it is not a deterministic model, right? Deterministic modules and non-deterministic modules are two kinds. Deterministic modules, they definitely work. They definitely work. There is a task given, it will 100% work. That is deterministic module, right? These are non-deterministic modules, right? They'll not, there is no guarantee, right? But when you include a non-deterministic module and a deterministic component, right? There is a enterprise application which is 100% working, right? You include an AI module, that a whole thing becomes a non-deterministic module. So that's a theoretical whatever. Okay, but we can make some components non-deterministic, some deterministic. Where the component is non-deterministic, you should be putting human interface, human intervention in there. Got it? You should be putting some human intervention so that they'll correct it, and the corrections can be taken as training data and retrain the model. That's how the system should be designed, at least for next 4 or 5 years in AI. Okay. The question, when I was consulting, in a company, we were working on some text data, and they don't have training data. And I said, we need to train and we need training data. Immediately they said, we don't have training data. Client will not give. No, client will not give. I know, right? The problem there is you need to build something with some accuracy, and along with the AI module, you should build a web application or an interface where user can correct the mistakes of the AI model. Okay, it is like a kid. You actually are training him, right? You will give some task, he will do it. He or she may be doing some mistake, you will be correcting him. Again, he will do it. Again, correcting. Again, like that, you will actually train. Like that, AI module should also be trained. Always you will not have training data. Over a period of time, you need to build training data by providing an application which has got AI module. At one point in time, whole industry will have lots of training data. Right? That's the direction the industry is moving. Okay. Some people, right, they talk like, there is no training data, we cannot do much about it. Yes, we cannot do now, but down the line, if you prepare data well, in 6 months, you can do many things. Do you agree? Do you agree with my statement?
Yes, sir.
So that's how we should be providing solutions, or we should be educating the client. Many people in the management doesn't know, even though they have learned AI, they will not get this gist of how to design an application and how to make the application more the advantage and disadvantage of AI is that only it will not work now. The advantage is that you can make it work at one point in time. Okay, so that you need to remember. Okay, topic modeling is also comes under that thing only. It may not capture 100% right, but give me 1 second. I'll actually try to get that data set. Right. Any questions in the meantime? HPC data I kept somewhere as HPC data. Healthcare product, HCP. HCP data. Give me 1 second. Any questions on this topic modeling thing? No? Okay, so now we are going to move on to deep learning. Before I go there, I would like to show a web application today. Sorry, right? I have found that web application here. I'll show that in a moment. Healthcare project. There should be data also here. I don't know. Where did I kept? Give me 1 second. The data set is very useful actually. HCP. I can see all kinds of stuff, but data is not available. Data cleanup is there. Give me 1 second, okay? Yeah, I'll have it somewhere here. See, I reorganized everything and I lost, I kind of. What the heck? If I see the path here, I'll be able to find it. Oh, workspace, okay. There I don't have it anymore. Uh, no. This may be one document, I think. Not the whole data. Let me open this and see. Oh, news data I kept it as. Where did I kept it as news data? I don't know. Dot / data. Do you see data here? No. Okay, I'll find it and I'll find it and put it on the drive. Okay, leave it for now. But I'll show you the what do you call it as how to build a model, right? How to build a model and deploy it as a web application. Okay, I have it. I found that example here. Where did I find POC demo somewhere? pickle file, stock market data. Yeah, this is the one. Okay, let me go to CMD. This is a Flask web application, right? To I don't know whether I have Flask or not. Give me 1 second. How to run a Flask application? I have to see it. Give me 1 second. Okay, let me install that. Conda install. I'll show you, right, how the pickle file can be integrated with web application and all that. This is like end of machine learning, okay, and we start deep learning. Okay, so now I need to say class.run. Yeah, started. Okay, so Flask actually looks for app.py. When you say flash.run, right, it will automatically run this app.py file. If you give some other name, right, we should say Flask app is equal to whatever the file name space flash.run. And then it will actually start it in this IP address, this URL. Right, this is the application. Okay, here I don't think this time series thing is there. Right, enter value as a list. I don't know what this is. Okay, regression, not found. Classification. So here, this is the credit card fraud detection thing, right? These are all the records which we loaded, right? 5 records we are loading, and then actual outcome, right? Actual output value is fraud, non-fraud, whatever, right? When I predict the web application will invoke a module, right? Anomaly detection ML module and random forest ML module, and then pass these records and make predictions and show it here. Okay, so clicking predict, see that, right? Anomaly detection module was right 4 times, random forest was right 3 times only. Okay, if you shuffle the data, the data gets shuffled, right? This shuffling and showing web application is all web technology. Okay, and when you click on predict, right, it is actually invoking a AI module. So I'll show you how exactly that AI module is getting invoked. So predict, see that both worked similarly. I shuffle, I predict, right? Almost all the time, right? The anomaly detection module or the random forest module will work same. Sometimes one will win, sometimes one will lose. Okay, got it? Any questions on this application? A simple web application this is. Any questions? No?
No, sir.
Okay, let me show you that web application. So here, see, right? Can you see? Yeah, you can see. I think this is visible, right? So here the application, right? This is Flask code. Flask is very easy to learn. Right here, the app name we have given as slash whatever, right? So that means the URL. This is the application URL, and slash classification is going to be going into this particular page. This page. Okay, this page code is here. So there is a template and all that for the web application, you know. And here we are loading the data file, and then we are sampling, right? Only 5 records, and then this guy actually took the data and concatenated the x value and y value, I think. And ultimately, right, he is actually invoking the method here. Multivariate Gaussian normal distribution, whatever that anomaly detection module. And then make classification, right? Make classification is a method down below, which is actually opening the CC fraud, credit card fraud detection module, and then making the prediction and returning the result. Right? This is a pickle file. We actually saved that model as a pickle file, and this method is invoking it, and that the result is being returned back. And that is actually being passed back to the template, and we are showing that in the classification.html. Did you get it at a high level? Somebody asked, I think, how we'll be using this in the web, in a real time or web application, or how to integrate an AI module, right? Did you get it? Is it easy? Instead of calling the service calls, right, we are actually making a call to this AI module. That's it. Okay, got it? Any questions?
Sir, but the app dot route slash classification, so that's nothing but the URL paths.
Yeah, this is like, RESTful URLs also we can build on it. If
Okay.
you return a JSON value, right, it becomes a RESTful value, RESTful, URL. If you return a HTML page, right, it becomes a web application. Flask is very easy.
I'm referring to the above
Yes,
line 18. Yeah.
yes, yes.
So that slash classification is what you showed in the web URL, correct? Sir?
Yes, sir.
Folder path or whatever.
If you know Java Spring, right, Spring framework, in that also we have these kinds of annotations, which actually make the URLs, right? So same kind of a thing they used here also.
Okay.
Yeah, for me it's been a long time, around 5 years. I touched Java, but Spring annotations only these guys are actually following, a kind of Spring annotations. Okay. So this is all Flask. This is all Flask technology. This is where these two calls are the AI modules, and we are loading those AI modules, right? These are the pickle files we save, and then if you have count vectorizer or standard scalar, all those pickle files you load here, and then transform, and then make predict. If there is transformation code, right, you'll put that code also here. You transform data, then load pickle files, then pass it to predict, and you get that result. Right? This code will become bigger, right? If you modularize the code into classes and methods, it will become easier for you to make calls or use reusability, right? Design patterns and reusability and all that stuff. Okay, got it? So good that I in the search for the other files I found this.
So we don't have the transformations over here.
No, we don't have, because this data, right, whatever you're seeing here is already numerical format, and there are no problems there. There are no nulls and all that. This is credit card fraud detection data. That anomaly detection data set I showed you, right? 2,80,400 records, and only 400 records are hard records and all that, right?
Yes, sir.
And very rarely it is failing. Very rarely it is failing. See that? This was built by Hanumantrao, one of our students. Right? This model was built by Hanumantrao. Website, this web page and the integration whole thing was done by Rahul. Okay. So that's it. That's about the ML part. Right. Let us jump into the deep learning a little bit. Right. So this is web application. Let me have it there. So now we'll start the.
Sir, this integration can be done with any kind of, the web application developed with any other language as well?
Yeah, any language. Here, right? Here what I did, this is a Python code, right? Everything is Python. So I just loaded this as a loaded inside the module. But this is not Python code. If it is .NET code or a Java code, you will write this particular function as a web service. Okay, and you pass record, right? Maybe 5 records at once, and then make it predict and return those five values.
That web service will be in Python?
Web service will be in Python. Web service code will be in Python, and using Flask or something, you should be building a Python web service, and then put this as a module there, and integrate.
So other languages can't understand the pickle files?
No, other languages cannot understand pickle files. Maybe Java can understand because it is Java serialization only. I never tried. Okay. Generally, it is, if you are to integrate, right, maybe you should dump it into a database and ask the model to run right after dumping, right? Every few minutes or few seconds, the model will check whether something is dumped into database and make predictions and put it in database itself and show on the website, or pass a XML file which actually takes and then it processes and returns back a JSON file or something like that to your web service.
Yes.
Or individual records also you can pass. It depends on how you design it.
Yeah.
Right? Okay. So we are done with machine learning. Right? One pending topic for a long time is recommender systems. I couldn't add it, right, because not getting time. You can actually go through, right? Now you can understand, because the basic math behind recommender systems is singular value decomposition. You understood it. That's not a big deal. So you go through the videos, and nowadays recommender systems are built using deep learning also. So there are some videos in YouTube and all that you can actually follow. Okay. And now so neural networks introduction. Let us let us stop the recording and start it again, because it's going to be a separate file.